question is from GATE 2016 Mechanical Engineering paper set 3 question number 32. A rigid rod AB of length L equal to √2 meter is undergoing translational as well as rotational motion in the XY plane. See the figure. The point A has velocity v1 equal to I plus 2j meter per second. The end B is constrained to move only along the x direction. Magnitude of velocity v2 in meter per second at the end B is dash. Let's have a look at the system. Now in this system we see that this bar AB is a rigid bar. One of its ends is moving with velocity v1. So when A moves with velocity v1, this bar is subjected to both rotational as well as translational motion. All the points on the bar are going to move translationally and the bar as a whole is going to rotate. This rotation can be assumed to occur around a imaginary center or imaginary point called instantaneous center. That instantaneous center can be obtained by drawing lines perpendicular to the velocity direction. So if we draw a line perpendiculars to both the velocity directions, we can obtain the instantaneous center at their intersection. This is nothing but the instantaneous center I. Now, angular velocity of this bar can be calculated as omega equal to velocity v1 upon IA, that is distance between the point which is having velocity v1 and the instantaneous center IA. This angular velocity will be equal throughout the bar because this is a rigid bar. Its angular velocity will be equal for each and every point on it. Hence, we can equate to the angular velocity calculated using point B. Point B has a velocity of v2 divided by the distance between instantaneous center and B is IB. Now, to find out v2, we will also need the magnitude of v1, which we do not have. And other thing, we need distance IA and IB. We need to calculate IA and IB. Let's see how we can find it out. To calculate the magnitude of v1, first we need v1 is equal to, it is given in vector form, I plus 2j. That means horizontal component is 1, vertical is 2. We can find out magnitude of v1 to be under root 1 square plus 2 square, which is nothing but root 5 meter per second. Now direction of v1, that means this angle we need to find, the red angle. Let the angle be alpha. So we'll write tan alpha is equal to opposite, that is vertical component is 2 and adjacent component, horizontal component is 1. So we have tan alpha is 2 by 1. Therefore, alpha can be tan inverse of 2. Value of tan inverse 2 in degrees is 63.44 degree. So we have magnitude of V1 and direction of V1. This angle to be 63.44. This length is already given to be root 2. We can find out this small angle. So we will have two right angle triangles. One is this is a right angle triangle. If we extend it, we see it. And this is also a right angle triangle. So we can find out this angle as 90 minus 63.44. This calculates to 26.56. So if this is 45 degree, this is 90, this is also 45. Angle ABI is also 45. Hence, these two sides will be equal to each other and they will be root 2 into cos 45, which is nothing but 1. This side is also 1. So to calculate total distance IB, we will have to calculate this side of the smaller triangle, and IA will be given by the hypotenuse of this smaller triangle. Let this point be C. In triangle ACI, we can write cos of 26.56 to be adjacent side 1 divided by hypotenuse IA. Therefore, IA can be written as 1 upon cos 26.56. This gives us distance IA is 1.118 meters. Similarly, we can also find IB by finding first IC. IB will be equal to IC plus CB. CB is already known to us as 1 meter. We'll have to find IC in the same triangle. It will give us IB is equal to 1.4999. Substituting these values, along with the magnitude of V1 in the previous relation that we obtained as equation 1, we will get V2 is equal to IB upon IA into V1, that is 1.4999 recurring divided by 1.118 into root 5. When calculated in digital calculator, this value comes out to be 3 meter per second. Let's fill in the answer. We have magnitude of velocity V2 in meter per second. At the end, B is 3. To learn about relative motion in detail, you can refer to the NPTEL video, Lecture 26, Relative Motion 3 and Instantaneous Center from the course Engineering Mechanics by Professor K. Ramesh. He is from IIT Madras. I hope the solution will help you clear it out. Thank you.